Hi ladies and gentlemen, welcome back. Today we're going to be going over expressions and equations and some of these past state test questions from 2021 and older. So we split the packet up into two parts. This is going to be part 2. We're going to start with question number 2. So which expression is equivalent to 60 minus 3y minus 9? So we're going to zoom in here and I want to combine the like terms. I'm going to use a highlighter here. 60 is a constant and minus 9 is a constant. Remember, we want to circle or highlight the sign that is in front of our term as well. So we're going to combine 60 minus 9. That's going to give us 51. And we can't combine the 3y with it because y has a variable. All right, now we want to look at which of our answer choices is equal to 51 minus 3y. So let's take a look at option A. We're going to use our distributive property to multiply 3 times 17. That's 51. And then also 3 times y would give us 3y. Our subtraction sign is going to come down between them. Right? So far A is equivalent to our original expression. Let's make sure no other ones are equivalent to it. So we're going to do here 3 times 20, again distributive property, that's 60. 3 times y is minus 3y. That subtraction sign is coming down. And then we're going to subtract 3 at the end. We're not distributing the 3 all the way to the end here because that minus 3 is not inside the parentheses with the 20 and the y. All right, now we're going to combine our like terms. 60 minus 3 is 57. So 57 minus 3y is not the same as 51 minus 3y. Choice C, when we distribute this, 17 times 3 is 51. 17 times y is 17y. We'll bring our subtraction sign down. So that's not the same, 3y and 17y. And our last option here, 20 times 3 is 60. 20 times 3y is 60y. And minus 9 here at the end. So we've got 60 minus 9. These two are going to combine to 51 minus 60y. It's not the same as 51 minus 3y though. All right, let's go to question number 3. Which expressions are equivalent? All right, so we've got pairs of expressions for each of these choices. We want to see which ones are equal. So let's zoom into A here. X plus x plus x is really 3 groups of x or 3 times x. That is not the same as x to the third power, right? X to the third power really means x times x times x, not addition. All right, we have C here. Let's take a look at this one. Let's distribute. 4 times 3 is 12x, and 4 times 4 is 16x. So these two are equivalent. 12x and 16x are the same. So far C, let's make sure B and D are not correct, right? I'm going to combine my like terms. 14x minus 2x is actually 12x plus 10, not 16x plus 10. Right? And choice D here, we cannot combine the x squared with the x. They are not like terms. So our expression here on the left side, that's as far as we can go. We can't combine anything. And that is not the same as 17x squared plus 10. So the correct choice is choice C. Right, number 4. Which expression is equivalent to 5 times 4x plus 3 minus 2x? So again, we're going to use distributive property here. 5 times 4 is 20x, and 5 times 3 is 15. So we've got 20x plus 15 minus 2x. We're going to combine the like terms, 20x minus 2x. That's the same as 18x plus 15. All right, and I can see as I zoom out, that is option A. Number 8, which expression is equivalent to, this is the exact same question. It's going to be choice A, 18x plus 15. So let's skip to number 9 here. Which expression is equivalent to 5 times 6x plus 3y? We're just going to use distributive property here. 5 times 6 is 30, so that's 30x. And 5 times 3y is 15y. All right, so that is option D. That's the same. All right, number 10, which pair of expressions is equivalent for any variable value greater than 0. So they're saying pick 1, pick 2, pick 3 to represent our variables. We want to know which ones are equivalent. We're actually going to use our number properties and combining like terms to see if they're equivalent. So we'll zoom in here. I'm going to distribute 3 times x is 3x, and 3 times 2 is 6. So that's 3x plus 6, not the same as 3x plus 2. So those two are not equal. For C, we're going to combine the f's. F plus f is the same as 3f plus g. Not the same as 3f times g. So no good. Choice B, 4d plus 2e. We can't combine these. They're not like terms. It's definitely not the same as 8 groups of d plus another group of e. So no. Right, and then we've got b plus 3c. Well, that's 2b plus 3c, and that is equal to 2b plus 3c. So choice D. All right, let's go on to number 11. Which expression is equivalent to 4 times p plus r minus 2p? So let's distribute. 4 times p is 4p, and 4 times r is 4r. So we've got 4p plus 4r minus 2p, and we're going to combine our like terms. Remember to highlight or circle the sign in front of that 2p. It's 4p minus 2p. That's going to be 2p left over plus the 4r, and that is choice C. Number 12, which expression is equivalent to the expression 5 times 2x plus 3 plus 2 plus x? So we're going to distribute here. 5 times 2x is 10x, and 5 times 3 is 15. And we're just going to drop the parentheses here. There's nothing that we need to distribute. We can drop the parentheses because it's all addition here, and commutative property tells us we can add in any order. We're going to combine our like terms now. Right, so that's 10x plus x, which would give us 11x. I'll use a different color for our constants. Right, so that's 15 plus 2, which is going to give us plus 17. That's choice C. Number 13, we're going to use the distributive property here to determine which ones are equivalent. So 2 times 4x gives us 8x, and 2 times 5 is 10. So 8x plus 10, choice C, is equivalent to the original. Number 14, which pairs of expressions are equivalent, or which pair? All right, so I'm going to zoom in here so we can see. Most of these require the distributive property, so let's use it here. 8 times 2x is 16x. 8 times 3 is 24. All right, over here, 4 times 4x is 16x. 4 times 24 is 96. Those are not equivalent. Choice C, 2 times 8x is 16x. 2 times 12 is 24. Right, now we've got 8 times 2x, that's 16x. And 8 times 3, also 24. Those are equivalent. Let's make sure choice B and D don't work. Right, 4 times 4x is 16x. 4 times 6 is 24. Over here, 8 times 2x is 16x. But 8 times 24 is, I believe, 192. I'm going to double check that. Yep, 192. All right, those are not equal. Then we've got 2 times 8x, which is 16x. 2 times 24 is 48. So 16x plus 48. And over here we've got 4 times 4x, which is 16x. And 4 times 24, which is 96. Not equal. So that was choice C. Number 15, which expression is equivalent to the original here, 4x plus 3z plus 5y plus 3x plus y? So we're going to combine our like terms. The x's get combined together. 4x plus 3x is 7x. And I see we can combine the y's as well. We've got y here plus another 5y. That's 6 groups of y altogether, or 6y plus the 3z. That's choice C. Okay, next, number 16. Which pair of expressions are equivalent? All right, so 7 and 2 can be multiplied together. That's going to give us 14x. That's not equal to 9x. 3x plus 5x, when we add the coefficients, becomes 8x. That's not equal to 15x. Choice C. We're going to distribute. 4 times 2x is 8x. 4 times 6 is 24. We'll bring the subtraction sign down. That is equivalent to 8x minus 24. And let's just confirm here. Yep. This would have to be multiplication, not addition, for it to become x to the 4th power. This simplifies to 4x. Not the same. All right, let's go on to number 17. What quantity could go in the blank to make the equation below true? Well, if I group these together, that's going to give us 3x. What should we add to 3x to make it into 5x? It has to be 2x. 3x plus 2x gives us 5x. All right, number 8. They're telling us the two expressions below are equivalent. What does that mean? That means for any value of y that we substitute in, that our equations will be equal. I should say our expressions will be equal. They will have the same value when we simplify it. We could put a negative number in, we could put 0 in, we could put any positive number in. When two expressions are equivalent, it doesn't matter what value you put in for y. As long as it's the same in both expressions, they will simplify to the same value. So that means we're going to choose choice A, any value of y, right? Not just whole numbers, not just odd numbers, not just even numbers. For any value, you could substitute it in. Number 19. A student formed a pattern in which each term is represented by a sum. The first 4 terms of the pattern are shown below. Which expression can be used to determine the value of the sum in any term n? So this seems really complicated, and I told you guys in class that substitution is a very valuable tool. And I said try to pick a number that is not 0, 1, or 2. So let's try substituting 3 into each of these expressions or answer choices to see if it equals 1 plus 3 plus 5, which is 9. So let's try it out for A. We've got 3 to the 2nd power. That's 3 times 3, which is 9. All right, let's try it for B. 4 times 3 is 12, right? That's not the answer we want. N is 3, we're saying, so that would be 3 plus 3. That's equal to 6. Not the value we're looking for. We're looking for 9. And 2 to the n power would be 2 to the 3rd power. That's the same as 2 times 2 times 2, which is 8. Also, not the value we're looking for. We're looking for 9. So it's choice A. All right, number 21. The area of Brian's rectangular garden in square feet can be found by using the expression 6 times 2x plus 5y. Use the distributive property to write an equivalent expression for the area of Brian's garden. So we're going to multiply 6 with all the terms inside the parentheses. All right, so 6 times 2x will give us 12x. And 6 times 5y gives us 30y. So our equivalent expression is 12x plus 30y. Now we're going to use our expression that we just wrote to find the area of Brian's garden in square feet. The x is equal to 3, the y is equal to 4. All right, so I'm going to rewrite our expression, 12x plus 30y. And we're going to substitute in. Remember, 12 and x are being multiplied together, and 30 and y are being multiplied together. So 12 times 3 is 36. Order of operations, we need to multiply before we can add. And then 30 times 4 is 120. When we add those together, we end up with 156 square feet. All right, next. going to go to number 23. A hotel has a number of meeting rooms, M, available for events. Each meeting room has 325 chairs. Write an equation to represent C, the total number of chairs in all of the meeting rooms at the hotel. All right, well, they have a number of meeting rooms. It could be 1, 2, 3, 4, 5, 10, 20, we don't know. Each of these rooms has 325 chairs. So let's say they have 2 meeting rooms, right? To find out the total number of chairs, we would have to multiply 325 times 2 to equal the total chairs. Right? I think that would be 650. All right, so I'm going to use this information to help us set up our equation. It's going to be 325, that's the number of chairs, times the number of meeting rooms, that's going to be M, and that's going to represent C, the total number of chairs altogether. So 325M equals C. All right, now, next part, use M equals 7 in your equation to find the total number of chairs in all the meeting rooms. So we're going to substitute in here. 325 times 7, that's going to equal C, our total number of chairs. And I'm going to do that multiplication on the side here. You should show your substitution, right? Show this, keep the original equation, and put 7 in for M. All right, so that's 35. 7 times 2 is 14, plus 3 is 17, and 7 times 3 is 21, plus 1 is 22. Right, so that means C is equal to 2,275 chairs. Right, now let's go to number 24. 24, the weight of an object on the moon, M, is about 1/6 of the object's weight on Earth, E. Which equation represents the approximate weight of an object on the moon in terms of the object's weight on Earth? So I'm going to highlight some information here. M is about, I'm going to get rid of the word about, 1/6 of the object's weight on Earth. When we're translating, we said the word is represents an equal sign. So M is equal to 1/6. This word of is multiplication, so I'm going to put a dot here. And the object's weight on Earth is represented with the letter E. So which one of these is equal to M equals 1/6 times E? Well, it's not A, 1/6 plus E. We can cross that one out. Choice B, M equals E over 6. That definitely works because 1/6 times E, I'm going to put E over 1, because E is just a whole number, or can be a whole number. And when we multiply across, 1 times E is E in the numerator, 6 times 1 is 6. So that is choice B. All right, number 25. The table below lists the coordinates of 4 points. If X represents any number in the first column, which expression can always be used to find the value of Y in the second column? All right, here again, I would suggest using some substitution. So let's take X is equal to 3 and substitute it in. We want to find when is it equal to 9, or which one of these options here will it equal 9 when we put 3 in for X. All right, so I'm going to do 5 times 3. 5X means 5 times 3. That's 15. It's not what we're looking for. It's not 9. All right, now we've got X plus 2, so 3 plus 2, that's equal to 5. Also not what we're looking for. Then we've got 3 plus 4, that's 7. Still not what we're looking for. So it should be our last one. 2 times 3 plus 3, well, 2 times 3 is 6, and 6 plus 3 is 9. So it's choice D. Number 35, a restaurant used 231 eggs last week. Of those, 46 were brown in color. The remaining eggs were white in color. Which equation can be used to solve for W, the number of white eggs used last week? All right, so we know 231, I'm just going to jot this out. That's all the eggs. Has to equal the brown eggs plus the white eggs, right? We know 46 of them were brown, and we don't know how many white eggs there are. We're going to use W for that. and that's got to equal 231. So which one of these equations is the same as 231 equals 46 plus W? Right, and that is choice B here. Right, we've rearranged our numbers, we've flip-flopped the 231 and the 46 plus W on either side of the equal sign, and that's okay. All right, number 39, I had it split up into two parts here. I apologize. Let me just erase the title here so we have some space. Okay. At the end of a baseball game, the players were given the choice of having a bottle of water or a box of juice. Of all the players, 12 chose a bottle of water, which was 3/4 of the total number of players. Write and solve an equation to determine P, the total number of players at the basketball game. All right, so I'm going to highlight some important information. 12 chose water, which was 3/4 of the total. I can change this into present tense, which is 3/4 of the total, right? So 12 people, players, chose water is, I'm going to translate into the word equals. So 12 players is 3/4 of the total number of players. Well, we know we're going to use P for the total number. So I'm going to replace the total, the word total, with P, and we're going to replace the word of with multiplication. You can use a dot or nothing at all. So 3/4 times P equals 12. Now we want to solve it. So we want to figure out, and there's no set strategy that you have to use here, right? I know that P has to be bigger than 12, because if we were multiplying 1 times P, that would equal 12. But we're taking part, 3/4 is a part, it's smaller than 1 whole. So that means P has to be bigger than 12. Right? So we can use some guess and check here. I know our number has to be divisible by 4 because we end up with a whole number. So the next number that's divisible by 4 bigger than 12 is 16. So let's try substituting in 16. And I'm going to put it as 16 over 1 so we can cross reduce. 4 and 16 are divisible by 4. Right? We end up with 4 for the 16, and 3 times 4 does equal 12. Right? So I guessed correctly with the 16. Now, we also, some of us talked about this in class on how to undo multiplying by 3/4. That would be dividing by 3/4. So if I divide both sides by 3/4, I would have to do 12 divided by 3/4 equals 3/4 P divided by 3/4, right? Then the dividing by 3/4 and the multiplying cancel out. 12 divided by 3/4, we can use keep, change, flip. That's going to be 12 times 4 over 3. I'm running out of space here. 12 times, we can cross reduce, sorry, the 3 and the 12 here. And 4 times 4 gives us 16. Right, so there were 16 total players in the basketball game. Last question here. A store sells 2 different packages of glue sticks as described. Actually, I'm going to keep that there. Okay, as described below. Package A has 18 glue sticks in it. Package B has 12 glue sticks in it. Write an equation for package A and an equation for package B that represents the total number of glue sticks in P packages. Well, let's think about it. If I buy 3 packages, I'm going to have to triple the amount of glue sticks, 18 times 3, to give the total number of glue sticks. So it looks like for package A, we can say 18 times P packages will equal G, the total number of glue sticks. Using that same thinking for package B, we would do 12 times the number of packages. That would equal the total number of glue sticks. All right, Mr. Davis buys 5 packages of the package A glue sticks. Mr. Wilson buys 8 packages of the package B glue sticks. Use your equations to find the difference in the number of glue sticks that each person purchased. So they're telling us to use substitution here. They want us to use our equations. So let's just organize our work here. Mr. Davis, 5 for package A, just jotting some information down. Then we've got Miss Wilson, who bought 8 packages of B. All right, so we're going to use the equation 18P equals G, and we're going to substitute in P equals 5 here. So 18 times 5, that's going to give us all the glue sticks that Mr. Davis bought. All right, 5 times 8 is 40. 5 times 1 is 5, plus 4 is 9. So that means we have 90 glue sticks for Mr. Davis. We're going to do the same over here. We're going to use 12P equals G, and we'll say P equals 8 because Miss Wilson bought 8 packages. So 12 times 8 equals G. 12 times 8 is 96. So Miss Wilson bought 96 glue sticks. Now it's asking us to find the difference in the total numbers. So we're going to subtract those two amounts, and that gives us a difference of 6 glue sticks. And that's our final solution and our final question. All right, if you have questions, you're welcome to check in with us on Google Classroom, email me, or ask about these in class. We'll see you soon.